Hi everybody, welcome to 85 Studios. My name is Elijah. This is going to be an electronics video, short and sweet. Okay, so this module right here, this is called a PSOM module. What it does is it hides up underneath the speedometer inside the instrument cluster of the 1995 through 1998 Ford F-250 models. And what it does is it takes the speed sensor signal from the speed sensor in the back axle and converts it into a digital signal that the powertrain control module, ABS module, and the, I believe, odometer and speedometer can then use to detect the vehicle's speed. Now, it's very important because when it converts the speedometer and odometer, the vehicle speed sensor signal over, it controls the speedometer, and the speedometer is a stepper motor, so then it uses this chip right here, actually. This is EEPROM programmable, to let you know how fast you're going. Not only that, it lets the powertrain control module know when to tell the E4OD transmission to shift gears. Without this module, or if this module is damaged, then you will not get out of first gear. Your transmission will not shift at any speed because this sensor is no longer able to tell that powertrain control module when to shift the transmission. So we have a failure. Actually, I don't know how well you can see it. Right here next to the capacitor here, this is the capacitor. And this right here, well, I'll point at it with the diode I'm replacing it with. This diode is a SMD surface mount diode that goes right between here, and it has to be pointed this direction with the gray facing towards the capacitor, as the one was that I pulled off of it. And I already did that off screen here, off camera, and I also pulled the module off camera. Because it was a little bit of a pain to go ahead and do that and pull that off of there. What I'm going to do is I'm going to go ahead and build up this area here with some solder, and then clip the leads on this new diode, and that should actually fix the problem. Now, what has happened in this circuit, and the reason why it is like it is, I'm going to turn the light on here. The reason why it is like it is this right here. This is called an MOV, metal oxide varistor. And what it does is it detects overcurrent. And if it is seeing overcurrent, such as if you were to jump start a vehicle, or if you were to jumpstart a vehicle with a bad battery, the bad battery isn't conducting anymore, and so it doesn't have a internal resistance that would drop that voltage down from the alternator. The alternator can actually make upwards of 300 to 400 volts, which at some amps would actually have caused either this to burn out. I've seen them burn out where this is burned up and the circuit trace here is burned up as well, which this one seems to be in good shape there. But the diode is actually in line with it. And I will go ahead and pause here and show you the actual schematic for the PSOM module before I do this. But I'm going to go ahead and stop the camera here, and I'm going to go ahead and I'm going to clip the leads on this new diode and put it in place so that you guys can see the install. And this is going to be a quick video. I'm not going to do anything real fancy with it. So if anybody knows electronics, take a look at this schematic. You'll know exactly why when the MOV conducted due to high transient voltage and high amps, it burned out. Now, that diode, bear in mind, that diode was only able to handle about maybe 1.5 to 2 amps. There is a 15 amp fuse in line with the circuit, but this is going to burn out before any 15 amps goes through it. So, bear with me, I'll be right back. And there you go. Repair complete, facing the right direction and everything. Supposed to be with the line towards the capacitor, and that's going to be your negative side. So basically, the power is going to, excuse my fat finger, power is going to come in here, and it's going to go down that diode, go into here, and what this does is it's got two plates inside of it with opposing forces. No, I'm thinking of something else. That's a resettable fuse. So this VOM, it acts like a diode. When you test it, it's going to be a diode across here. It'll only conduct in one direction. I'm sorry, I said VOM. This is an MOV, metal oxide varistor. So the way it works is it acts like a diode. It's got a semiconductor junction all the way across from plate to plate. And I can show you that also while we're doing this. I'll just cut away for a second here. This is a metal oxide varistor, and this is what it looks like in the schematic form, and this is what it internally is. So it's got a PN junction, and as the voltage spikes, it conducts at a higher, a lower, actually, resistance. It has a fairly high resistance until it sees a higher voltage, and generally they'll set them, like this one for instance, it's set to 12 volts. But I think it'd probably be around 14 or 15 volts, maybe 16 volts. So once it starts seeing upwards of that rated voltage, whatever that may be, it starts conducting at a much lower resistance. And what that does is it shunts that voltage to ground. As per our schematic here, it shunts this voltage to ground. And what that does is it creates a high resistance, it creates a low resistance in the circuit itself at the power input. And what that'll do is it will protect the sensitive electronics over on this side of the board from being damaged by those high voltages. And as you can see, it's quite the complex circuit here. It's all SMD, except for we've got some dip packages here, capacitors. We've got these four prongs here. Basically all they do is they hold the these are power output to the stepper motor on the speedometer. So it sits directly behind the speedometer, and it takes care of all this sensing and sending and converting to digital signals. Now this right here, this is actually the blade connector for your speedometer, odometer, the odometer digital readout, and this has a digital readout on the odometer. So it's a kind of a cool system, a little bit ahead of its time, I would say, as far as being 1996. Personally, what I would have done if I was building this circuit in particular, yes, I would have used an MOV, but what I would have done is either shunt it into a thermistor set for a certain heat limit, or I would have put a poly switch, resettable fuse, automatic resetting fuse in front, in between this diode and this junction. Unfortunately, I can't do that right now because I don't have any on hand, and I can't find any that are rated for 12 volt 1 amp, but that diode is actually rated for 1 amp. So that's a 900N. That's rated for 1 amp. So as far as this connector goes here, this is all of your input, and that pin right there, right at the tip of my finger on the corner, is pin 1. That's battery on, always hot, or battery always hot. Second one next to it is going to be accessory on, and what that's going to do is it's going to light up everything once the accessory is on. But you have to have a constant battery power in order for the trip meter to have power constantly, so that it does not reset, because it is resettable. Now, on the reverse side of this, you have these two here, these two button switches here, push buttons, momentary contact, and what they're for is your this is for your trip odometer, and also you can use this to program the chipset inside of here, so that you can set it for your wheel size, or you can set it for various different other specs. There's different things you can look up online that you can do with them. And this one here is to switch between trip odometer and your miles, your regular odometer. So what I'm going to do is I'm going to go ahead and reinstall this in the truck and see if it will shift, because before, with that diode blown, I was not able to get out of first gear. And everything else worked. Odometer, speedometer, everything else, tachometer, you name it, everything worked. Tachometer is going to have a similar system, but the tachometer's got everything built in, so it doesn't need a board like this to function. So all it does is it takes a speed sense signal off of the engine instead of the rear wheel. And I can show you that sensor also. The wiring is traveling up in a harness, and we've also replaced that speed sensor. So we did testing on this, and the diode came back faulty, so we replaced the diode, and hopefully now I can't think of why we would have had such a high current for a long period of time from any other portion of the vehicle, unless somebody was jump starting it and either jump started off a battery and then took the battery off while it was running after they got it started, which could cause that, or if for some reason the battery had a bad connection. You want to be extremely careful when you're jump starting vehicles, because like I say, if you ever take that battery off of the circuit while the engine is running, the alternator can generate upwards of 300 to 500 volts, which can destroy things like this, with a lot of amps too. And voltage is nothing without amps. Voltage won't flow. Current is when you have something connected to a circuit. Voltage is initial. So voltage won't flow unless you have something going from positive to negative. Even in AC circuits, the only difference is they're switching phases. They're switching between positive and negative polarity at 60 or 50 hertz depending on where you are. So you always have to have amps with your initial voltage. Now, the amount of amps that you can actually pull out of a circuit depends on its weakest link. So the fuse is always supposed to be the weakest link, which the fuse, I'll show you here in a minute, it was supposed to be the weakest link. But what happened was I had installed that new stereo head unit, and if you look back in my videos, there's a different, the stereo head unit. I originally thought that that was the only thing on the circuit, but it turns out that this and several other modules are also on that circuit. And when I replaced the fuse with a higher rated fuse than it was 15 amp, it actually, because it had been blowing that fuse, I thought that the stereo head was blowing that fuse. It actually had gone to the weakest link, which was of course this diode right here. So this one's rated for 1 amp, and if this MOV can't handle more than 1 amp and there's a power surge, I would like to go in line with this battery hot and put in a poly switch resettable fuse, something that's rated for maximum 16 volts at 1 amp. So that way it'll trip and then it'll reset, rather than that way this module is protected. And I'd like to do that with the other modules. Unfortunately, I don't believe that that's going to be possible, especially since I do not know where all the other modules are, and tearing into them unnecessarily would be kind of a bad thing. If they're not broken, don't fix them. although I did see some serious issues with this module and the way that it's designed. With that, thank you to FordTruckEnthusiasts.com for your forums where I was able to find the schematic and the diagrams for this. Thank you to Amazon.com for having these diodes here and available for me to purchase. Also, another thing that they were saying is this guy right here, this electrolytic bipolar, or it's not bipolar, electrolytic capacitor is actually a major source of leaking electrolyte out. This guy here, the round one, not the MOSFET. This is a transistor actually, in a heatsink. But yeah, he's famous for leaking. He doesn't look like he's popped, and see the safety cap isn't popped, it didn't cracked. What'll happen is if you overvolt that, it'll pop open and vent. That's the safety vent, so they don't explode. And this is 100 microfarad at 35 volts, I believe. Let me see if I can focus on it. Yeah, 100 at 35 volts. And I did a number on that sucker with that. Did a number on that insulation with that solder iron. Whoops. It's okay, it won't leak. They're strong components, but you just got to be real careful, because now if that touches anything, that's your ground side. And you see the line there, this line on the outside, that's your negative. They're polarized. They are polarity sensitive. If you put them in reverse, they will explode or vent. Not good. If you overvolt them, they'll overheat and they'll pop that vent, the safety vent. It'll start steaming and blowing out all kinds of electrolyte and goo and meltdown. Sometimes they even light on fire if you really do it overdone. But I've actually, this has been a learning experience, and this has been kind of a fun project for me. Learning what all of these things are and what they do, and kind of studying up on them a little bit. And now hopefully if we put this module back into the truck, we will have a shift, so we'll take it for a test run. I also have another project coming up that I'm working on that's going to be a camera system for the truck. Onboard 4 cameras, so that we can do videos similar to a dash cam, but more like a DVR, that will allow us to take video and play videos. So stay tuned for that video. I don't know if it's going to be next or if something else is going to be next on the channel, but stay tuned for that if you like the electronics portion of the channel, as well as the mechanical portion of the channel and the automotive portions of the channel. There will be more of that still to come. So let's go drop this thing in. It's going to be instantaneous for you guys, but it's probably going to be 3 or 4 hours for me. So I will cut the video and let you guys see what we've got when we put it back together. Take care till then. Okay, so what I've done here is I've attached the module and the ribbon cable up to the, neighbors are being loud, attach it to the actual speedometer. Speedometer's on a stepper motor, there's no cable, so if you move it, nice free moving stepper motor. And this actually goes on second to last. That module, this one slides under here, but I have to put the other modules in first into the instrument cluster. So I'm going to go ahead and do that. Basically, we go left to right. This one goes in, just line up the pins. See the pins? See the pins? And what the hell is that guy doing? He drunk or what? Okay. That was fucking weird. But yeah, anyway, line up the pins. And there's only, these are pretty much specific to what they are. So these are the pins that you're lining up. and those will hold those gauge clusters in place. This one, the speedometer needs to go in before this one, and the speedometer is going to go under this lip. So, because the speedometer's actually got these here on it. Alright, so all you need really, there's all the screws, the screwdriver, and this actually goes in right here. So that's actually got a cable, physical cable on it for this. It connects to your shift knob, this, and it's just got one bolt that holds it down. So we didn't lose any hardware, we kept it all safe here. Everything's separated by what it is. We should be able to do this. I'll see you when I get it back together. The cluster anyway, I'll show you. Alright, so we've got the module all put back together. Everything's looking good. These are clicky clacky. These are clicky clackly. There were 2 screws here. I wasn't so sure, but I have all of the screws. I think they actually went inside, here, inside there, instead of the ones that I put in there. They're short and they're black, as opposed to being long and brass, but it doesn't really matter to me at this point. Yeah, these here. Doesn't really matter to me at this point because everything's going to work when I put it together. So now the only thing left to do is connect this connector up to the PSOM and see if it smokes or not, which I'm dreading. So I suppose let's do it. I mean, what do we got to lose? It'll either shift and work, or won't shift, or won't work. And incidentally, fuse number 8. Fuse number 8. Let me take my... I've got all this apart. Fuse number 8 is gonna be... let's see. Barely read that, guys. Supposed to be a 15 ampere, and that is going to be top, second one from the top. On the top, second one, that's a 15 ampere right there. And that is 15 amp, and that is what it's supposed to be. So that burned up even with a 15 ampere in it. Now, is this fuse blown? That's the question. Let me grab this, something to take it out with. Gotta turn that light off. You can't see. It looks good. One way to find out for sure, though, on fuses, get you a voltmeter, put it on diode, and hit select until you see this little symbol right here, and then you can bring it across your fuse, and if it conducts, it will beep for you. You can't see this because I don't have it on camera, and I can't get it on camera because I only have 2 hands. Sorry, guys. It's good. You can hear it. Yep. So I'm going to place this back in. This goes right here. Fuse number 8. Actually, right in there, like so. There's a mosquito. A mosquito trying to get me. Alright, so I'm going to snap this module back in, put it in the dash, and, ooh, I got him and he was full of blood. Ew, not my blood. They don't usually bite me for some reason, I don't know why. But, I'll do that. I'll let you know when it's back in the dash, and we'll take it for a test ride. Alright, so we've got the module all put back together, and I even put this shift lever little cable back on. I don't know how well you can see that, but as I shift down in gears, you can see actually that it is, let me see if it'll let me, no, it won't let me zoom here. Okay, not once, it's already recording. Weird. But yeah, so we've got, as we shift gears, I've adjusted that so it goes in Park, reverse, neutral, drive, 2, 1. Full tank of gas. Of course, the temperature is going to be cold because it hasn't run in probably a week. Tax down. Odo's down. Speedo's down. Got 8 volts. Let's see what happens when we start it. Wow. Okay. Voltmeter goes up. Tachometer's working. Won't know if any of the other gauges are working. We got oil pressure. Man, she's burning really lean, which in the computer world of automotive translates to rich. System 2 lean, bank 1, bank 2. We got a glowing beacon of a check engine light over here because of system 1, bank 1, bank 2, PSOM 1, PSOM 4. I'm sure you mechanic folk out there are familiar with that one. Those are the lean codes. But yeah, we've got those. We've got a idle air overrun, which we'll figure that out a little bit later. Idle airspeed, that's going to be your it's a little valve that sits on top of the engine. I forget what it's called. I have replaced them before, but not on this vehicle. She starts. Let me go put the facets back on. It's getting dark. Kick panel's down here. I've got another one here. This is the bezel. So we'll put the bezel back on. And we'll start back up the video and go for a test drive. Sound like a plan? Well, it's looking like everything is back together. I'm gonna grab my panel light because it's getting dark out. And it's way down in first gear. And actually, that shows that it's in first gear. Now you get a reflection on it. See, yeah, that's pretty cool. Let me turn the light on the phone. Boop. Yeah, so now when we shift it, there's second, there's drive, there's neutral, there's reverse, there's park. And we're in park. Bezel's all on. Oh, I forgot about these pretty pieces. I gotta put the pretty pieces back on. And they just kind of snap in there, just like so. Oops. That's the wrong one. These all work. Fogs. Fogs are pointed a little too far up actually to be fogs, but I need them for driving around here at night when I'm off the highway. This is actually broken, so even if I put the screw back in there, it ain't gonna matter because there's nothing gonna hold that. So I'm gonna 3D print something, and I have the screw for it. So we're good there. Now all the pretty pieces are on. Everything works. This is another thing that I'm working on, but this device does not work, so we're sending it back to get another one. And guys, let's start it up and take it for a test run. See how it do. All right, let's go.